Hello students, your teacher here, Mr. Sharasinski. Another episode of Algebra 1, Lesson 8.2, Graphing Quadratic Equations. And in Lesson 8.1, we learned a critical part of graphing quadratic equations, which is finding the axis of symmetry and the vertex, which are the first two steps in this process. And then I'm going to go ahead and read the final two steps. Step 3, put the vertex in the middle row of the table. Fill in a table of values using your calculator. And then step 4, plot the points and connect them into a smooth parabola. So let's go ahead and see how this works. Now, before we get started, actually, I want to say one thing, and that is you can graph any equation using a table of values. And the values that I recommend you use for x are 0, 1, 2, and -1, -2. These are the x values that are around the origin and usually will reveal to you the behavior of the graph, okay? So that was just a little side note. If you're ever asked to graph an equation, use these inputs for x, find the y values by plugging them in, and then you will be able to graph the equation. All right, erase that because we don't know what the axis of symmetry is. All right, so let's get started. Find the axis of symmetry. Well, I'm going to write over here A, B, and C. A is 1, B is 0. So x equals -0 divided by 2 times 1, and this is going to be 0. So x equals 0. My middle term in the table is going to be 0. And then what is y when x is 0? Well, y equals 0 squared. 0 squared is 0, so y equals 0. The vertex is at 0, 0. All right. So we're going to take 1 point to the left, or 2 points to the left and 2 points to the right. And we're going to use our calculator. So the best way to do this is to put the equation into your y equals. So we're just going to type x squared into our y equals. And then you're going to go to the table. So you go to the table by hitting second and right above graph, there's table. And there are all your values. So when x is -2, y is 4. When x is -1, y is 1. And they always reflect over the axis of symmetry or the vertex. So this y is 1 and this y is 4. And that is always the case for quadratics. They always reflect over the axis of symmetry because the axis of symmetry splits the graph into 2 equal parts. All right, so now we have our x and y values for each of the points. Let's go ahead and graph them. So we have -2, 4. -2, 1, 2. We have -1, 1. 0, 0, 1, 1, and 2, 4. So if we graph this, connect the dots. Okay, you can see the graph opens up because A was positive. Now, domain and range. This is something we haven't looked at since Unit 3. The domain is left to right. So does this graph have values for all the x inputs? And the answer is yes. This graph continues to the left and to the right to infinity. And then the range, well, it looks like the graph doesn't even start until y equals 0 and continues to go up. So y is greater than or equal to 0. Number 2, A equals 1, B equals 2. My axis of symmetry is -2 divided by 2 times 1. It's -2 divided by 2, which is -1. I'm going to go ahead and put that as my x value in the middle of my table. Now we need to find the y when x is -1. And plug in -1. Y equals -1 squared plus 2 times -1 minus 1. -1 squared is +1 minus 2 minus 1. So that's going to be negative 2. Okay, so we're going to do 2 points to the left and 2 points to the right. That's going to be negative 2, negative 3, and then 0 and 1. And I'm going to put this into my y equals on my calculator. So y equals x squared plus 2x minus 1. I'm going to hit second and go to my table. Remember, the table is above the graph button. And I'm going to plug in my values for y. When x is negative 3, y is 2. When x is negative 2, y is negative 1. When x is 0, remember these reflect, so this is going to be negative 1 and 2. All right, so the axis of symmetry was at x equals negative 1. The vertex is at negative 1, negative 2. So let's go ahead and graph our points. Negative 1, negative 2 is right here. 0, negative 1, and then 1, 2. And then negative 2, negative 1, negative 3, 2. Okay. Our graph opens up because A was positive. Connect the dots. And so, again, our graph continues to go to the left and to the right to infinity. So domain is all real numbers. And range, our graph does not start until y equals negative 2. And it continues to go up forever to infinity. So y is greater than or equal to negative 2. All right, number 3. A equals negative 1. B equals negative 8. So x equals, we're finding the axis of symmetry. Remember, the formula is negative b divided by 2a. So that's going to be positive 8 divided by 2 times negative 1. That's 8 divided by negative 2. So negative 4. So axis of symmetry is negative 4. Now to find the vertex, we plug in negative 4 and solve for y. So y equals negative 4 squared minus 8 times negative 4 minus 17. Negative 4 squared is positive 16 times negative 1 is negative 16. Negative 8 times negative 4 is positive 32. Minus 17. So negative 4 and y is going to be negative 1. And we're going to choose the two x values to the left and then to the right of our axis of symmetry in our vertex. It's negative 5, negative 6, negative 3, negative 2. And I'm going to go ahead and put this into my y equals. So y equals, type in the equation, the original equation, negative x squared minus 8x minus 17. Hit second table and just find your x values, negative 6, negative 5, negative 5, negative 2, and they reflect. So this is negative 2, negative 5. Go ahead and plot my points. Vertex is at negative 4, negative 1. Okay. And then negative 5, negative 2. Negative 3, negative 2. Negative 2, negative 5. And negative 6, negative 5. Graph opens down because the A was negative. Our domain for most parabolas, I'm going to say, yeah, all of them. Domain is all real numbers. Graph continues to the left and to the right to infinity. And then the range, here the graph starts at y equals negative 1 and goes down to infinity. So y is less than or equal to negative 1. All right, moving on. A few more examples here. Let's see, we got 8 more. Maybe skip one, I don't know, we'll see. All right. All right, number 4, a equals negative 2 and b equals 4. Find the axis of symmetry. It's x equals negative b divided by 2a. So that's going to be negative 4 divided by 2 times negative 2. Negative 4 divided by negative 4 is 1. So the axis of symmetry is that x equals 1. And then if we find the y value for our vertex by plugging it in, so negative 2 times 1 squared plus 4 times 1 plus 1. 1 squared is 1 times negative 2 is negative 2. 4 times 1 is 4 plus 1. So that is going to be 3. So the vertex is at 1, 3. Then I'm going to choose 2 points to the left. That's going to be 0 and negative 1. And 2 points to the right. That's going to be 2 and 3. And I need to use my calculator and type these in. If I do that, I should see that y equals negative 5 and 1. And then it reflects 1, negative 5. Okay, so let's go ahead and plot our points. Negative 1, negative 5, 1, 2, 3, 4, 5. 0, 1. 1, 3. And 2, 1, and 3, negative 5. And since A was negative, this graph opens down. Domain for all parabolas is all real numbers. And the range, it looks like the range starts here at y equals 3, and it goes down forever to infinity. So y is less than or equal to positive 3. Now I want you to pause for a second and think about A. So A in this graph was negative 2. So the negative means that it opens down. But 2, let's imagine this is just positive 2. What effect did that number being larger than 1 have on the graph? See what you can come up with. All right, so if you paused and you thought about it, you should notice that this graph is a little more narrow. So we call this stretching. If a graph, so here's like the normal parabola. If A is greater than 1, so 2, 3, 4, 5, 6, 7, anything in between, the graph is going to get skinnier, like it's being stretched vertically. All right, so that is one transformation that happens when the numbers change in quadratics. And you may or may not find that interesting. Number 5, A equals 1, B equals negative 6. Formula for axis of symmetry is negative b divided by 2a. So this is going to be positive 6 divided by 2 times 1, which is 3. So the axis of symmetry is at 3. And then we can find the y value. Y equals 3 squared minus 6 times 3 plus 11. 3 squared is 9 minus 18 plus 11. This is going to be 2. Okay. And then we choose 2 values to the left and 2 values to the right. That's going to be 2, 1, 4, 5. And the y values, go ahead and put that equation into your calculator. Then hit second table. And you should get negative 6, negative 3. And remember, it reflects over the vertex, so negative 3, negative 6. Okay, so the vertex is at 3, 2, and we have our points. Let's go ahead and graph them. So we have 3, 2, 1, negative 6, 2, negative 3, and then 4, negative 3, 2, 3, 4, and 5, negative 6. I was looking at my graph and realized it doesn't look right. And it's because these numbers here are not supposed to be negatives. Holy cow. So this is 3, 6. This is 3, 6. Okay, let's try this again. 1, 6. 2, 3. Connect the dots. Graph opens up because A was positive. Domain is all real numbers, and the range looks like this is at y equals 2, and it continues to go up forever to infinity. So y is greater than or equal to positive 2. Number 6. A is negative 1, B is 0. Remember, if B is 0, the axis of symmetry is going to be 0. Okay, so put that there, negative 1, negative 2, 1, 2. Now let's plug in 0 to the equation. If you plug in 0, hopefully really quickly you realize it's negative 2. All right, go ahead and put this equation into your y equals and go to your table to find the y values for these other points. Negative 2 is at negative 6. Negative 1 is at negative 3. Negative 3, negative 6. So our vertex is at 0, negative 2. Let's go ahead and plot our points. And our graph opens down because A was negative. And our domain for all quadratics is all real numbers. And the range, it looks like, starts at y equals negative 2, and it goes down forever to infinity. So the range is y is less than or equal to negative 2. Number 7, A equals 2, B equals 8. So x equals negative b, that's negative 8 divided by 2 times 2. That's negative 8 divided by 4, that's negative 2. Two points to the left, 2 points to the right. Let's go ahead and plug in negative 2 to our equation to see what y equals. Y equals 2 times negative 2 squared plus 8 times negative 2. Negative 2 squared is positive 4. 4 times 2 is 8. 8 times negative 2 is negative 16. So this is going to be negative 8. Okay. And then go ahead and put this equation into your y equals to see what the y values are for our other points. And if you do that and you look at your table, this is 0 and this is negative 6. Okay. All right, quick question. Which direction is the graph going to open? Pause, think about it. If you paused and you thought about it, remember A is what tells us what direction the graph opens, up or down. If A is positive, it opens up. If A is negative, it opens down. So this graph is going to open up. Negative 2, negative 8. And we have negative 3, negative 6. Negative 1, 0, 0. Negative 4, 0. And you can tell in this one where A was 2, similar to number 4 at the top of the page, the graph is a little more stretched, right? This is the vertical stretch we were talking about. Okay. So the vertex was at negative 2, negative 8. Domain is always all real numbers. The range, this one started way down here at the bottom at y equals negative 8 and continued to go up forever to infinity. So y is greater than or equal to negative 8. All right. Couple more examples and we're done. A equals -1, B equals 4. So this is x equals negative b divided by 2a, -4 divided by 2 times -1. -4 divided by -2 is +2. Axis of symmetry is at +2. 2 points to the left, 2 points to the right. All right, put this equation into your y equals to see what the y values are. Should have been doing this all along instead of substituting x in to find the vertex, even though it is good practice. 3, 6, 7, 6, 3. Let's go ahead and plot these points. 2, 7, 1, 6, 3, 6, 0, 3. Okay, connect the dots. Graph opens down because A is negative. Vertex is at 2, 7. Domain, all real numbers for all quadratics. And the range, it looks like y started here at y equals 7. It goes down forever to infinity, so y is less than or equal to 7. Number 9, A equals -1, B equals -2. X equals +2 divided by 2 times -1. That's 2 divided by -2. That's -1. So the axis of symmetry is at -1. 2 points to the left, 2 points to the right. Go to your and put this equation into your y equals. Go to your table and see what the y values are for these inputs. And if you do that, you should get -3, 0, 1, 0, -3. Remember, they reflect over the axis of symmetry. So the vertex is at -1, +1. And then let's go ahead and graph. -1, +1, 0, 0, -2, 0, 1, -3, and -3, -3. Connect the dots. This is our standard parabola. A is 1. Domain is all real numbers. Range, it looks like this graph starts at y equals 1 and goes down forever to infinity. So y is less than or equal to 1. Number 10, A equals -3, B equals -18, big numbers. X equals -b divided by 2a, so that's going to be +18 divided by 2 times -3. 18 divided by -6 is -3, so the axis of symmetry is at -3. 2 points to the left and 2 points to the right to complete the table. And then let's go ahead and put this equation into our y equals, look at our table to find the y values for those inputs. If you do that, you should get -5, 4, 7, and they reflect for -5. All right, so the vertex is at -3, 7. Okay, let's go ahead and graph that. -3, 7. And then -4, 4. -2, 4. -1, 5. Only one -5. 1, 2, 3, 4. There. And right there. Okay, connect the dots. Another example of A being greater than 1. So here it was 3. You can see this is even more stretched. Very narrow graph. The domain is going to be all real numbers, and the range, it looks like the graph starts at y equals 7 and goes down forever to infinity. Since it goes down, y is less than or equal to +7. And that is it. Last example. A equals 1/2, B equals -6. So here we have an A value that is between 0 and 1. So far, we've only seen when A is 1 and when A is greater than 1. We haven't seen a fraction as the coefficient to A. Let's go ahead and find the axis of symmetry, that's going to be negative b divided by 2a. So this is positive 6 divided by 2 times 1/2. 6 divided by 1. 6 divided by 1 is 6. So the axis of symmetry is at 6. 2 points to the left, 5 and 4. 2 points to the right, 7 and 8. Let's go to our table, put the equation into your y equals, and hit second table. If you do that, you should get these values for y from your inputs. It's going to be negative 5, negative 6.5, negative 7, negative 6.5, negative 5. Okay, so the vertex is at 6, negative 7. 6, negative 7, way down here. And we have 5, negative 6.5, so that's like right there. And then 7, negative 6.5, so like right there. 8, negative 5, 8, 1, 2, 3, 4, 5. And 4, negative 5. Okay. So the graph looks something like this. Okay. And hopefully you notice that this graph is actually a little wider than our previous graphs. So what we're revealing now is another transformation when A is between 0 and 1. Anytime A is between 0 and 1, there is not a stretch, there is a compression of the graph, which makes it wider, okay? Takes our graph and makes it wider. The range looks like it starts down here at y equals negative 7 and goes up to infinity. Since it goes up, y is greater than or equal to negative 7. Long lesson, sorry about that. I'm your teacher, this is the way.